Hello everyone. In this video I'm planning to discuss question number 16 to 19 of this paper, January 2022, paper 1 HR. Okay, let's start with question number 16. This question is related to arithmetic sequence. Its first term is given, term 1, a equals 1, and common difference is 4. So d equals 4. You need to find the sum of the series from 41st term to 100th term. You know the sum of n terms of the sequence, Sn equals n by 2 times 2a plus n minus 1 times d. This is the formula for finding sum of n terms. N represents number of terms, n by 2 times 2a, where a is the first term of the series, n is again number of terms, and d is common difference. So in this question they are given first term a equals 1, common difference is given as 4. So since you need to find sum of 41st to 100th term, let's see how the series is looking like. See, a1 plus a2 plus etc plus a41 plus etc plus a100. Suppose this is the sum of that 100 terms. Then to find sum of 41st term to 100th term, see, this sum you need to find. So to find this, let's find the total sum of 100 terms and sum of 40 terms. Then subtract this sum of 40 terms from 100 terms, so that you'll get sum of 41 to 100th terms. Okay, so to find sum of 40 terms by using this formula, it's S40 equals 40 divided by 2 times 2, a is 1, so 2 times 1 plus n is 40, so 40 minus 1 times d, common difference is 4, substitute this 4, so that is equals 20 times 2 plus 39 times 4, and that is equals 20 times in bracket 2 plus 39 times 4, close the bracket, equals 3160. So the sum of first 40 terms is 3160. Okay, now let's find the sum of 100 terms by using the same formula. So S100 equals 100 divided by 2 times 2a, 2 times 1 plus n is 100, so 100 minus 1 times common difference is 4, so that is 50 times 2 plus 99 times 4, that is equals 50 times 2 plus 99 times 4 equals 19,900. 19,900. Okay, now your aim is to find out sum of 41st to sum of 41st to 100th term. So as we discussed before, sum of 100 terms minus sum of 40 terms will give you sum of 41st to 100 terms. So sum of 100 terms is 19,900. Let's subtract sum of 40 terms from this, 3,160. So the answer is 19,900 minus 3,160 equals 16,740. Okay, now let's move on to the next question. Question number 17. This question is related to sets. They're given a universal set with 3 sets in it. Set A, set B, and set C. The number of elements are given here. Now the first question is to find number of elements of A union B. So from the picture it's clear A union B includes this region. See, this is the region A union B. Number of elements of A or B, this one. So that includes 6 numbers in this region, 3 here, 2 here, and 8 here. So total 19. So the number of elements in A union B is 19. Next is number of elements of A intersection B. Intersection means common elements. So if you consider set A and set B in this picture, you can see there is no common elements between this A and C. So the number of elements in A intersection C is 0. Number of elements is 0. Next, number of elements in B intersection C complement. That means the common elements of B and C complement. C complement means the set all the elements which are outside C. So let's shade the outside C in one way. See, this is C complement. So this is the C complement. And let's mark the region B in another way. So this is B. Now you need to look for the common region for C complement and B, and you can see it's the region shaded in both ways. That's this. So this is the region C complement intersection B, and that includes number of elements 3 in this part, 8 here. So total 8 plus 3, 11. So the number of elements in B intersection C complement is 11. Okay, next question is you need to find the number of elements of A complement, union B complement, union C complement. So to find this region, let's shade these 3 sets in different ways. So let's start with A complement. A complement is the region outside A. So let's shade the region outside A by using these horizontal lines. This is the region A complement. Now B complement. For B complement, we shade it in another way by using vertical lines. So it's outside B. So this is the region B complement. Now last set C complement, we use slanted lines to mark C complement. So this is C complement. So since you're looking for the union of three sets, you need to look for the region where there is at least one type of shading. If it is intersection, you need to look for all type of shading. In the case of union, you look for at least one type of shading. So you can see the whole region universal set is covered by at least one type of shading. So the total number of elements in this required set is sum of all these three numbers, and you can see it's 28. Next, question number 18 is from the topic similar shapes. In the question they are given the ratio of areas of shape A and shape B. Area of A is to area of B is 4:9, and the ratio of volumes of the next set of shapes B and C is given as volume of B is to volume of C equals 125 is to 343. Now your aim is to find out what is the ratio between height of A to height of C. This is what you need to find. Okay, so from the result of similar shapes, the relation between areas of two similar shapes is in this way. Area of first shape divided by area of second shape is equal to square of side of first shape upon a side of second shape. So from this relation you can find the ratio of sides. Height of A over height of B equals square root of ratio of areas. It's 4/9. It's 2/3. So the ratio of heights of first two shapes, height of A is to height of B is 2:3. So we found the relation between the heights of first two shapes. It's height of A is to height of B is 2:3. Now let's move on to the next two shapes, B and C. The relation is given as volume of B is to volume of C is 125 is to 343. You know the relation between volumes of two similar shapes is in this way. Volume of B over volume of C is cube of the ratio of the corresponding sides. So let's name it as height of B over height of C. So the relation between volumes of two similar shapes is in this way. Volume of B over volume of C equals height of B over height of C the whole cube. So now let's substitute the volume of B and C here. So it's 125 over 343 equals height of B over height of C the whole cube. Therefore height of B over height of C equals, by taking cube root on both sides, you'll get the expression for height of B over height of C. So by taking cube root, so cube root of 125 over 343, that's 5/7. So you have the ratio between heights of B and C as height of B is to height of C equals 5:7. Now we have the relation between height of A and B in the first part as height of A is to height of B is 2:3. And the second part you have the relation between height of B is to height of C is 5:7. Now to connect this A with C, you need to make this height of B part same in these ratios. So let's multiply the first ratio with 5 and second ratio with 2 to make these two parts same. So the ratios changes to height of A is to height of B is 10 is to 15, and the second one, height of B is to height of C is 15 is to 21. Now you can see now by using these two ratios you can connect height of A with height of C as height of A is to height of C equals, see this 10 is to 21. So by making this height of B same in these two ratios, directly you can connect the height of A with height of C, it's 10 is to 21. Okay, next question number 19. It's a question from fractional indices. The left side of this expression is given as cube root of 1 by x to the whole power 4, and right side is x to the power m. Your aim is to find out the value of m. So by using index rules, you can convert this cube root in the power form as 1 by x the whole to the power 1 by 3. Then you have the whole power 4 equals x raised to m, and that's 1 by x to the power, you can multiply these two powers by using the rule a to the power m to the power n equals a to the power m times n. So it's 1 by 3 times 4, so it's 4 by 3. So 1 by x to the power 4 by 3 equals x raised to m. That implies now if you distribute this power 4 by 3 to each terms, it will be 1 by x to the power 4 by 3 equals x to the power m. That implies x to the power negative 4 by 3 equals x to the power m by taking this term to the numerator part. So now if you compare these two, you'll get the value of m as negative 4 by 3. So the value of m is negative 4 by 3. Okay, next question number 19. It's a question from fractional indices. The left side of this expression is given as cube root of 1 by x to the whole power 4, and right side is x to the power m. Your aim is to find out the value of m. So by using index rules, you can convert this cube root in the power form as 1 by x the whole to the power 1 by 3. Then you have the whole power 4 equals x raised to m, and that's 1 by x to the power, you can multiply these two powers by using the rule a to the power m to the power n equals a to the power m times n. So it's 1 by 3 times 4, so it's 4 by 3. So 1 by x to the power 4 by 3 equals x raised to m. That implies now if you distribute this power 4 by 3 to each terms, it will be 1 by x to the power 4 by 3 equals x to the power m. That implies x to the power negative 4 by 3 equals x to the power m by taking this term to the numerator part. So now if you compare these two, you'll get the value of m as negative 4 by 3. So the value of m is negative 4 by 3. So in B part of the question, you need to write this quadratic expression in the complete square form. 3x squared plus 12x plus 19 in the form of a times x plus b whole square plus c. So for this, you need to make the coefficient of x squared 1 in the first step. So let's consider these two terms and take out this number 3 from these two terms as a common factor outside. So it's 3 times x squared plus 4x in the bracket plus 19 you keep outside. Now 3 times x squared plus 4x, to make these two terms a complete square form, I'm going to add and subtract a number which is square of half of this coefficient of x, which is 4. So half of 4 is 2, 2 square is 4. So if I add and subtract this 4, it will not change the value of this x squared plus 4x, but it will help you to write the complete square form. Plus 19 is there outside. So by using these three terms, x squared plus 4x plus 4, you can write the complete square form as x plus 2 whole square. You can see this is the expansion of x plus 2 whole square. And how do you get this form directly from this? You take the square root of x squared, that is x, and look at the sign of the second term. If it is plus, you keep the plus sign here, and square root of this number is 2, and write the complete square form. Okay. If you expand this x plus 2 whole square, you'll get this x squared plus 4x plus 4 and minus 4 inside the bracket. So use the square bracket to differentiate these two brackets, and 3 is there outside plus 19. So from these three terms, you will get this complete square form by taking square root of x squared, that's x, and use the sign of second term, it's plus, and square root of the third term is 2, and write it as complete square. Then minus 4 is there inside the bracket and plus 19 outside. Okay, so that is equal to, let's expand this bracket by multiplying 3 with each term in the bracket. So 3 times x plus 2 the whole square minus 3 times 4, 12 plus 19. That's 3 times x plus 2 the whole square plus 7. So that's the complete square form of this algebraic expression. If you compare with the standard form, you can see the value of a is 3, b is 2, and c is 7.